All right, so last time we looked at section 2.4, that was on solving inequalities. Very similar to solving equations, except when we multiply or divide both sides by a negative, we had to flip the inequality. But we still looked at inequalities that were just linear. Something like that. What we're going to look at today is what happens if you have something that's not linear, okay, like a quadratic inequality. Well, the method that we're going to focus on is a method that's going to work if it's factorable. Okay? If it's not factorable, I can show you something else we'll do. Right? But we're going to focus on ones that are factorable at first. All right, so we're going to look at projectile motion again. It's something we've already done. But there's the formula in case you need that again. So remember that the height of a projectile in this type of motion is given by negative 16t squared plus v sub 0 t plus s sub 0. Okay. Formula assumes that your units are in feet and seconds for the time. So last time we used this formula, we calculated when an object was at exactly a certain height. This time, we're going to calculate when an object is above a certain height. So we might have like a greater than symbol instead of an equal sign there. Okay? And that's going to result in an inequality, but it's going to be quadratic. Okay? It won't be linear. All right, so for this one, we're going to be throwing a ball straight up from ground level with an initial velocity of 80 feet per second. Okay, so let's see what it is they want to know. Okay, well, there's our formula. So what I've done there is I filled in 80 for the initial velocity. That's the v sub 0. And what was the initial height in this one? What's the initial height, Vanessa?
It was ground level.
Ground level, which would mean what? 0. Yeah, it was on the ground, which is why I didn't put plus s sub 0, because it's starting on the ground. Okay, so we've got an equation right now that represents that situation. And now we want to figure out when the ball is at least 64 feet above the ground. What inequality symbol means at least? Declan?
Sorry. You'd be using a greater than symbol. I'm not sure I got the question. I'm sorry.
So when when we use the phrase at least, what inequality symbol is that?
It would be greater than or equal to.
Greater than or equal to. Yeah. So whatever we set up in this problem, we're going to be using a greater than or equal to. So they want to know when the ball is at least 64 feet above the ground. Okay? So in other words, when is the height of the ball greater than or equal to 64? So all we have to do is fill in a formula for the height, but that's exactly what we have up above. The height is negative 16t squared plus 80t. So that's the height, and we want to know when that is 64 or higher. Okay. All right, so that is a quadratic. What do we generally get? In this case, it won't be equal to because it's an inequality, but when we are solving an equation, what do we try to get on one side of the equation for a quadratic? Yep.
0.
0. So we're going to do the same thing here. Right? We're going to try to get that 64 on one side. All right. Now, what I'm going to do is I'm going to put the 64 on one side, and then we can look at solving it. Maybe we'll do this one on the calculator, and then the next one, that's what I was just looking at, we'll do algebraically. Okay. All right, so let's put this on the calculator and let's put everything on one side. All right, so I'm going to put that in on y1, and I'm going to be looking for where my graph is at 0 or higher. So let's put that in. So we got negative 16x squared plus 80x minus 64. Now, as far as my window, we know that time can't be negative. How long is the object in the air for? Well, we don't know that yet, okay? Because once it comes back down, then the height is at 0 again. I'll have the object going for 10 seconds. And if that's not high enough, I'll adjust it. But the height, well, ground level is the lowest we can go. And what's the highest? We don't know. Let's try going up 100 feet. So set our window. Okay, so I got a lot more room there than I need. I am going to zoom in to make it easier to see. So what I'm going to do is, let's set the Ymax. Let's try that at like 60 to make that a little bit better to see. Okay. That looks good. So we're looking for where this object is 0 or higher, which means visually we're looking for where it does what? What are we looking for on that graph? Follow the brush.
Other times it's 64 feet or above.
So what am I? So when I'm looking at this picture, where would I look to find where that inequality is greater than or equal to 0?
Near the peak.
Near what?
The peak.
That would be like a maximum height of the object. So we don't want to look at the peak for this one. Anyone else? Where do we want to look? Yeah?
The x-intercept?
The x-intercepts. Okay, so we are looking for the x-intercepts. So we're going to do second calc 0. Let's see, I don't know if I can do this. I might have had to set my window a little lower because I need to go to the left, which is technically off the screen. Might work. Let's try it. Yeah, it did work. Okay. So my first x-intercept is at 1. And my second x-intercept, so we'll calculate our 0. And again, anywhere to the left is fine. That works. Even though we can't see it, I know we're definitely to the right because I can see the dotted line. And the guess, we'll just put that anywhere. And I got x equals 4. So when is this object above 64 feet, based on what we just solved? How about Dari?
At 1 in 4 seconds? Or, wait.
It does have something to do with 1 in 4. Can you say that again? Just how you worded that?
At 1 in 4 seconds? Or would it be like,
Well, at 1 in 4 seconds, the object is either, it's exactly at 64 feet. But we want to know, the question is, when is it above or equal to 64 feet?
between?
Between, yeah. Anytime between 1 and 4 seconds. That answers this question. Okay. Remember, we're not looking for a 64 this time because we moved the 64 to the other side. If we hadn't moved the 64 to the other side and we graphed it like this, then we could have done this same problem as an intersect. Okay, it would look a little bit different. But if I had put the 64 on one side, put the negative 16t squared plus 80t on the other side, now you'd have something more like this. I got to adjust my window, though. Let's put the window back up to, I think I had it at 100. Let's do like 120. Okay, so now there's your object. That's the left side of what's in this box. There's 64 feet. And now, instead of thinking of it as an x-intercept, which is the way we did it, because we put everything on one side, now you could think of it as an intersect. So now you'd be finding where these two cross. And if you do the one on the right, you get 4 seconds. And if you did the one on the left, you would get 1 second. So you can think of it as either an intercept if you put everything on one side, x-intercept. Or you can think of it as an intersection problem if you leave it the way it was. And you do not put everything on one side. But either way, you will get between 1 and 4 seconds. Okay, so answering the question, when is it at least 64 feet off the ground? Between 1 and 4 seconds. If you wanted to write that as an interval, you can include the 1 and you can include the 4 because it is exactly 64 feet at that time. If it said, when is the ball above 64 feet, then we would have used parentheses on that interval. Okay, so any question on that? We want to get used to doing it the first way by calculating the zeros, because when we get into factoring, you're going to have to get everything on one side to do it. Okay? But I guess technically, if you wanted to do it graphically, the way I did it here, it's okay to do that method as well with an intersection. All right. So now, next one. How long does the ball stay in the air? All right. What do we know about the ball if it's in the air? This is going to help us to set up an inequality to solve. Yeah?
Would it just be above 0 feet?
Yeah, if it's in the air, then the height is above 0, right? So this time, we're going to do the same thing, except instead of setting our height greater than or equal to 64 feet, we're going to set our height greater than 0 feet. As long as it's greater than 0, it's in the air. So our height is, again, go back to your formula, negative 16t squared plus 80t. Now, because you're finding when it's in the air, it's automatically already greater than 0. So 0 is by itself. Okay, so what can I factor out on the left-hand side? Jade, what can I factor out there?
T.
Yep, t. And what about for a number?
4.
We can go even bigger.
8.
Yep. How about bigger?
16.
Yeah, we can factor out a 16, and let's take a negative with it. So let's factor out a negative 16t. Okay, what would I be left with inside the parentheses if I factor out negative 16t? Yep.
T minus 5.
T minus 5. All right, now we gotta think about that a little bit. We've got something times something, and it has to be bigger than 0. Right? What do we know about t? What kind of number does t have to be? Or you could tell me what kind of number it doesn't have to be, one or the other. So how about, tell me what kind of number it has to be. Yeah.
Positive.
Positive or
0.
0, right? You could say it can't be negative, right? Which means it could be positive or 0. So t is always a number that's positive or 0. If you plug in a number here that's always positive or 0, what kind of number is always going to result from that calculation. If you plug in a number for t that's positive or 0. And let's say positive, because technically we want the ball to be in the air. If the time was 0, that's at the beginning of the experiment, the ball's still on the ground. So let's say that t technically has to be greater than 0. So if t is greater than 0, what kind of number is this green circle always going to give us? Yeah?
Negative.
That's always going to be a negative. There's nothing you can do about that. Okay? If you plug in a positive value for t, positive times negative 16 is always a negative. So that's a negative. What kind of number would this have to be in order to get a result that's greater than 0? Yeah?
Negative.
That has to be a negative. Right? It has to be. You have no choice about this being negative. So if you want to get a positive answer, you've got to do a negative times a negative. So now, the question is, when is this a negative number? If we can figure that out, that's when the height of the object will be above 0. Okay, so when is t minus 5 negative? What kind of values of t would cause this second factor to come out negative? Anything that's what? Yeah?
Less than 5.
Less than 5, yeah. So when does t minus 5 come out negative? As long as t is less than 5. So what does that mean? It means the ball is in the air less than 5 seconds. Okay, like 4.9 repeating. At 5 seconds, it's exactly back on the ground. Okay, so the ball is in the air for less than 5 seconds. Okay, and when is the ball at least 64 feet off the ground? We already did that graphically, so I'm not going to do it algebraically yet, because I want to show you. Something first. Okay. So the method that we're going to look at to solve these inequalities is going to depend on a lot of things like that. When is a factor negative, or when is a factor positive? Right. So the method we're going to look at is called a sign pattern. Okay. When you have a linear factor, a linear factor is like t minus 5. A lot of times we use x plus 3. That's a linear factor. Has a variable to the first power, plus or minus a constant. How many numbers can you plug into that to make it exactly 0? X plus 3. Yep. Only one number. Okay. Every linear factor has exactly one number that you can plug in that would make it 0. In the case of that one, it's negative 3. So negative 3 is kind of the dividing point. If you plug in negative 3, you're going to get 0. If you plug in numbers bigger than negative 3, well, something's going to happen. And then if you plug in numbers smaller than negative 3, something else is going to happen. Finding that number that causes it to be 0 is very important. That's what's going to help us to solve our problems. So here's a couple other examples of linear factors. If you had a factor t minus 1, you could plug in 1, and that would give you 0. Now that you know that, if you plug in numbers bigger than 1, you're going to get a positive result. If you plug in numbers less than 1, you're going to get a negative result. Now, do you want a positive or a negative result? Well, that depends on the question. Depends what you're looking for. But you can now figure out both. Okay, for the bottom one, if you plug in negative 4, you get 0. Then if you plug in numbers bigger than negative 4, you'll get a positive result. Less than negative 4, you get a negative result. So what we'll do is, once we figured out the root, or the 0, for our linear factor, then we're going to graph that on a number line. When we put it on a number line, we're going to mark the number that gives us 0. So like if I was going to do this one, mark the zeros, -4, and then label each section of the number line. There's 2 sections, one to the left, one to the right. Numbers in the right section are going to give you a positive result. Like if you plug in a number like -1, okay? Plug that in for t, that's a positive result. If you plug in numbers in this section over here, that's going to give you a negative result. So this whole method depends on being able to factor the problem. If you can't factor it, then this whole method's not going to work. Now, when you factor a quadratic equation, how many factors do you get? You factor quadratic. And we just did one in the last problem. You always get 2. Okay, so factoring a quadratic resulted in 2 factors. This method I'm showing you will work for anything you can factor. Cubic, quartic, as long as you can factor it into linear factors, this method will work. Okay, and then once we have a sign pattern picture for each individual linear factor, so if you had 2 factors, you're going to draw 2 number lines, then we're going to take and combine them all together. So you'll make a number line for each individual factor, and then you'll put them all together to kind of get your final answer. And whether you're looking at a product of factors or you're looking at a quotient, the method doesn't change. Okay. So let's try solving our first quadratic inequality. Okay, and this will be factored. Okay, so first step, make our parentheses. And we are going to be looking for where something is greater than 0. So when we're done, we're looking for a positive result. Okay? One thing I should mention is if your inequality is not already isolated with 0 on one side, you need to do that first. Anytime you're factoring, you've got to get 0 on one side. All right, but we already have that. We got 0 on one side. What's going to be my first term in each parenthesis? I'm going to need a what and a 1. Yeah, Lance?
Would you need an x and a constant?
We are going to need an x. I like that. That's good. But then x times what is 2x squared?
Oh yeah, you need some what's it called? X and a coefficient.
We're going to have a coefficient. Yep.
That's something with x.
Something with x.
What times what equals -5?
Not yet. We're just trying to get this one.
Just 2x.
2x squared.
Wouldn't it just be 2x?
2x, yeah. So we need a 2x and a 1x. Okay, what about my signs in parentheses? Annalise, what are my signs going to be? A what? Well, if you put a negative and a negative, they would multiply to give you a positive. Positive and negative. And it does make a difference which one we put where, because we have a 2x and an x. So what order do you want to try? Positive with the 2x. Okay. So we'll try that. And now I need 2 numbers that multiply to give me 5. Okay. How about Gregory? 2 numbers that multiply to give me 5?
2.5 times 2.
Generally, when we're factoring, we want to stick with integers. Yeah.
Like 1 and 5.
1 and 5. Okay, and I'll try them in the order you just said, but we may have to switch those. Let's check it. 2x squared That's going to give me minus 10x plus 1x. That's going to give me a negative 9x for the middle. What do I need? How do I fix that? Because I don't want negative 9x. Yep.
You swap the sign.
Swap the signs. So we need the plus there. We need the minus there. Now 2x times 5 is 10x. Negative 1 times x is negative x. 10 take away 1 is 9. Perfect. Okay, so now we factored it. Okay, so the next step is draw a number line for each linear factor, mark the 0, and then determine where it's positive and negative. Okay. So I already have my number lines ready. What would make this first factor 0? What would you plug in for x? Yeah, Nick?
1/2.
Yep, plug in 1/2. So this isn't to scale or anything. We're just putting 1/2, and then we'll figure out where it's negative and positive. And then what would make the x plus 5 0? Travis?
-5.
-5. And put that anywhere we want. Just put that there. Okay. Now, in this factor, if I pick a number bigger than 1/2, okay, so to the right, and I fill it in for x, what kind of answer will I get? If we plug in a number bigger than 1/2, yep,
Positive.
we're going to get a positive. And if we plug in a number smaller than 1/2 for x right here, we'll get a yep.
A negative.
We'll get a negative. Let's do the same thing on the bottom. So if we plug in a number bigger than -5, Layla, what kind of number will we get if you plug in something bigger than -5 right here?
Positive.
Yep, you get a positive. And if you plug in a number smaller than -5, you'll get a negative. Okay. So now we know what kind of numbers are going to result in a positive and a negative in each individual factor. Now we have to put it all together and look at the product of the individual factors. Right? So when you put them together and look at the product, you're going to make a number line, and it's going to have both zeros on it. -5 and 1/2. And that's going to separate your number line into 3 sections. Let's start in the -5 section. Okay, Ethan, if I am lower than -5 on this number line, what section would I be in?
Negative.
I'd be in the negatives. And if I'm lower than -5 on this number line, what section would I be in?
Negative.
I'd be in the negatives. So if you pick a number lower than -5, you're going to be in the negative on both. And a negative times a negative gives me
Positive.
a positive. So looking at combining these two together, numbers lower than -5 in this product will result in a positive answer, okay? A greater than 0 answer. That's something we're going to be interested in. We want to know where the result is positive. So now we know one section where it happens. Everything below -5. Okay, let's look at between -5 and 1/2. In the top number line, if I'm between -5 and 1/2, what section am I in on the top number line? How about you, Jackson?
Negative.
Yep, you're somewhere right in here between -5 and 1/2. That would give you a negative. What if you're between -5 and 1/2 in the bottom number line?
Positive.
Yep, you'd be in the positive. That would put you right about there somewhere. And if you multiply a negative times a positive result, you will get
Negative.
a negative. Okay, that's not something we're interested in because we want to know where things are greater than 0. If you plug in numbers in that section, you're less than 0. So now let's look at greater than 1/2. Okay, top number line. If we plug in a number greater than 1/2, what section are we in? Lens?
Positive.
Positive. So let's write that down. Positive. What if we plug in numbers greater than 1/2 in the bottom number line? What section would we be in there? Yep,
Positive.
be in the positive. So if you plug in a number bigger than 1/2, you're going to get a positive result here, positive result here, and the product of a positive and a positive is a, Vanessa?
It's positive.
That's a positive. Okay. So now that diagram is going to tell you your answer. When you go back and look at your original question, you're either looking where you were above 0 or below 0. We're looking for above 0. So there's 2 sections where you are above 0. This section and this section. How would you describe all the numbers in that green interval number 1? And I'm looking for set notation. The lowest value, comma, the highest value. And then brackets or parentheses where you need them. Yeah, Jackson.
Would be like open parenthesis, negative infinity,
Yep.
-5, open parenthesis,
Yes.
and then or
Or
open parenthesis, 1/2, infinity,
infinity.
and then open parenthesis.
Perfect. That's exactly how you write your answer. That describes the first green interval, and that describes the second one over there. Okay. Any question on that one? All right, let's try another one. Now, this one is already factored for you. Okay, it's a cubic. Factoring's already done, so you don't have to worry about that part. We just need to graph our number lines. All right. So how about Marcelo? If you look at this first factor, what could you plug in here to make that 0? 0. Yep. And Jaden, what could I plug in here to make that 0? -3. And Annalise, what could I plug in for the bottom one to make that 0? Yeah, 1, which I guess I need another number line. All right. And now we'll go through all the intervals. Nick, if you take 0 and plug in a number to the right of it, what kind of result would you get right here?
Positive.
And to the left of it?
Negative.
Okay. And that's pretty much how it's going to be for all of them. The only way it can switch is if you ever had a negative in front of the x. Then that could switch the positive being on the right and the negative being on the left. But yeah, so this is going to be positive, negative, positive, negative. Now, when I combine all these together on the same number line, how many sections am I going to have on my final number line to look at? Annalise? Yeah, we're going to have 4. Okay, it's always one more than the number of factors. So you're going to have 4 sections. And the boundaries between each sections are those numbers. -3, 0, 1. It doesn't have to be to scale. All I have to know is what's happening in each section. Okay. So let's look at numbers lower than -3. Dario, if I'm lower than -3 in the top number line, what section am I in?
Negative.
Negative. How about lower than -3 in the middle number line?
Negative.
Negative. And lower than -3 in the bottom number line?
Negative.
Negative. So that would result in a negative in all 3 spots. And then the product of those would result in a negative. Yep. Okay. Now let's look at between -3 and 0. So Travis, in the top number line, what kind of number would I get if I was between -3 and 0?
Negative.
Yep, negative. How about Ethan, what kind of number would I get in the middle number line if I was between -3 and 0? A positive. And Lenz, what kind of number would I get in this number line if I was between -3 and 0?
Negative.
A negative, yep. And then the product, Layla, of a negative, a positive, and a negative would be a positive. Now, I don't know if you've noticed the pattern, but in the final answer, the sections always alternate. Negative, positive, negative, or positive, negative, positive. Okay? So once you know, technically, once you know the first one, it's going to alternate from there. But I always check the first 2 just in case I made a mistake on the first one. And now we are looking for where we are greater than or equal to 0. How many sections on that number line for the final answer give us a result greater than or equal to 0? Lens?
It would just be like anything after 0, so it would just be like negative and positive on the right side.
So how many, so we got a total of 4 sections, and you're saying how many?
2.
2, yep, I agree, there are 2. What are the 2 sections that give you a number that's greater than or equal to 0?
Would it be the negative or positive on the right side? Would it just be like the positive suggest?
Can you give it to me as an interval?
Oh, as an interval.
Yeah.
So I guess it would be starting with an open bracket for 0.
So yep, we do need a bracket. And then what's the low value that you're looking at?
Would it be 0?
What sections are you looking at?
I'm looking at 3 and 4.
So they want to know where we are greater than or equal to 0. Section 3 is negative results. That wouldn't be greater than or equal to 0.
So would it just be number 4?
So for this problem, this essentially means where are we going to be positive or technically higher? So you have to look at those words. Right here, you're going to be positive, and right here, you're going to be positive. So it's intervals 2 and 4. So you're not looking at the number you're plugging in. You're looking at the result of the number you're plugging in. So it's like the output, right? The y value, what would happen, not the x value. It's perfectly fine to plug in -2 here, right? And you will get an answer that comes out positive. This isn't saying that x has to be 0 or higher. This is saying y has to be 0 or higher. So our first interval is from -3 to 0. And we can include that because there is an equal to under the 0, under the inequality sign by the 0. Or how would we describe the other interval? Yeah? Parenthesis, yeah. Yep. Remember, when we have an unbounded interval, we have to use a parenthesis, not a bracket on that. Yeah. Okay, so that's how you solve that one. Okay, any question on that one? All right, for this one, I just kind of want to look at what's going to happen once you get your whole number line set up. So you got a result at 4, that's your first 0. positive, negative. Here, you're going to get negative 5 halves, okay, when you solve the bottom one. So negative 2.5. Positive, negative. And they want to know where you're going to be less than or equal to 0. Okay, when you put all of that together, you have negative 5 halves. What's the other one? 4. If you pick a result that's below negative 5 halves, you're going to be in the negative section on this one and the negative section on this one. And when you divide negative by a negative, that gives you what kind of number? Ethan?
Negative. No, positive.
No, positive. How about if I pick a number between negative 5 halves and 4, and I fill it in right here? What kind of answer will I get? Yeah? Yep, I'll get a negative result. Because if you're between negative 5 halves and 4, that's a negative. Between negative 5 halves and 4 would put you over there, that's a positive. And a negative over a positive is a negative. Okay. What I'm interested in is how we write the answer this time. We're looking for where we have negative results, or 0. Negative or 0. How many sections here would satisfy that? How about Marin? How many sections here would give us a result that would be less than or equal to 0? So how many?
1.
Yeah, just one. There's only one section that gives you output values that are 0 or lower. That is right here. How would you describe that answer this time? About Declan, how would you describe that?
I'm sorry, I have to say that again.
So how would you describe the interval that we just circled?
The interval that you just circled, it would be
In set notation.
in set notation. Is this the same formula from? Was this based on the same formula from before, with the greater than equal to symbol with the 0, or is this a new formula?
Well, you're going to use brackets or parentheses.
That's
Yeah.
That's what I was talking about. That's why I was asking about the greater than equal to symbol, because that would determine whether or not I'm using brackets or parentheses.
Partially. But go ahead.
Partially. It would be brackets negative 5 halves, comma 1 bracket.
And what's your high value in the interval?
That would be is that a negative 1? Or is that a 1? Or is it 4? Sorry.
It's a 4. It's a 4. So put a 4 and then bracket or parenthesis.
That'd be bracket still, or?
Yep, would be a bracket. Does everybody agree with that? What's wrong? Something's wrong. Yeah?
Would the maximum value have to be a negative as well, or at least below 0? Or wait, is that for the x?
So these values, yes, these are domain. This is range. So the domain of numbers you can plug in is that interval, but it's not, there's a problem with how we wrote it. What's wrong there? Yeah?
Is it the fact that like you can, and this one you can divide by 0, so
Uh-huh.
it can't be about. Like the bottom one we gotta solve and see what makes it equal to 0.
Well, we've already done that. Yeah, when I had to do that to make these number lines. Yeah?
You'd replace the first bracket with parentheses.
Right, this needs to be a parenthesis. Even though it does say you can be equal to, you can't be equal to if it would cause you to divide by 0. So in this interval, the 4 is okay to equal that one, but not the negative 5/2 because it was in the bottom of the fraction. Okay. So you still have to watch out for things like that when you describe your intervals. Don't ever divide by 0 or square root of a negative. That stuff still applies. Okay, any question on that? All right, so last thing we'll look at in this section is if you can't factor it, then we will graph it. Okay? So not every problem is going to be factorable. So let's try this one. And there are two approaches. You can leave it the way it is and graph what's on the left in y1, the right on y2. I think I showed you how to do that on the rocket problem. Or you can put everything on one side and deal with zeros. I'm going to do it the second way. Right? We did the rocket problem. I'm going to leave what's on the left the way it is. I'm going to leave what's on the right the way it is. And I'm going to graph two separate things. Okay, so let's put in x cubed minus 2x squared minus 5x plus 7. And we've got, what is that? 2x plus 1. Okay, so I am looking where my cubic is above the linear. So let's do zoom 6. And we're looking for where the cubic function is above the linear. Well, there's your cubic. And the red one is going to be your linear. Perfect. You can, with a standard window, you can see everything you need to see. Let's put that graph over here. Okay, how many intervals are we going to have to describe to explain completely where the cubic is above the linear? Yeah.
3.
Okay. If I just describe, let's just call these points, just so we have locations, A, B, and C. So explain to me where your intervals are.
Oh, between A and B.
Between A and B, I would agree the cubic is above the linear. Yep.
Oh, so there's only one.
No, I think there is somewhere else that the cubic goes above the linear too.
After C.
After C. That's an unbounded interval. After C, never stopping. So yeah, there are two sections between A and B and after C. So when we write this, let's start with that symbol. And does it say in this problem that we can equal the two functions, or do we have to be strictly above the linear? Which one is this? Marcelo?
Equal.
Yeah, it can be equal. So that means once we figure out what A and B are using the calculator, we can equal A and we can equal B. That's fine. If that equal to wasn't there, I would have just used parentheses. I don't have any fractions in this problem, so I don't have to worry about dividing by 0. How are we going to write the interval from C and up? Well, Gregory, how am I going to write that interval? You don't have to give me the numbers yet because we don't know them.
So just like ABC.
You could just leave it blank, like the first one.
Okay.
Just the symbols.
Bracket and
Mhm.
parentheses.
Yes, because what's going to go right here? This we do know.
Infinity.
Yep. So that's pretty much how your answer is going to look. Now you're going to use second calc intersect to find all those x values. All right. So we'll do second calc intersect. Okay. You need all three of them. Okay. So it doesn't really matter which one you do first. So this is from A. This is like B. 0.76. Okay, so that one's 0.76. Second calc intersect. Move your cursor closer to that one. That's negative 2.26. And then one more time, second calc intersect. Uh, 3.51. So if you plug in an x value between negative 2.26 and 0.76, you will be somewhere on this section, which makes the cubic above or equal to the linear. And then if you pick a value that's 3.51 or higher, you will be on this section. And that cubic is just going to keep going up, almost vertical. And this linear function is going to keep going like that. So the cubic is always going to be above the linear after point C. But you got to be 3.51 or higher to be in that section. Okay, any questions on that? Okay, let's take a look at last thing for today. So as far as the algebra, I think the first section here is a little bit harder because you have to remember how to do the factoring. This section is a lot more visual, less algebra. So we talked about the terms polynomials. So we want to kind of understand what a polynomial is. So in general, a polynomial is an expression. It has coefficients in front of the variables. It has exponents. And generally, the way you write a polynomial is the exponents go down. They decrease. So you might start with like an x to the third. Then you have an x to the second. Then you have an x to the first. And then you don't have any x's left. Okay, then you just have a constant. You cannot have any negative exponents or decimal exponents in a polynomial. No negatives, no decimals. So this is not a polynomial. X to the 3.4 power. Nope, not a polynomial. This also is not a polynomial. Why not? Doesn't look like we have any integers there that are not negative for the exponents. Or do I? Why wouldn't that be a polynomial? Yeah?
Because when it's solid, you need to 2x and -2.
Yeah, if you simplify that, right, this is really like having 2x, or I'm sorry, having 2 over x squared. Well, when you have an x squared in the bottom, that's equivalent to writing x to the -2 power. That has a negative exponent, even though it's not written that way. Okay, so no variables in the bottom of a fraction. That would not be a polynomial. Okay, so that's the general pattern. These numbers in front can be decimals. That's no problem at all. Like 2.4x squared, that's definitely a parabola. Yeah. No imaginary numbers anywhere. No imaginary numbers in front, no imaginary numbers for the exponent. Definitely no imaginaries. Don't worry about that right now. So as long as the first term is not equal to a 0, like I'm saying, if you did something like this, well, that wouldn't count, right? But as long as you don't put a 0 for the first term like that, then usually the highest exponent is the degree. The reason that this would not be a 4th degree polynomial is because you're multiplying it by 0, which effectively does this. That's not even that. Okay? So if you multiply something by 0, then let's filter that out first. Whatever's left, the highest exponent is called the degree. What do we call a polynomial that is degree 1? What kind of polynomial has a degree of 1? Marcel?
Linear?
Linear. How about degree 2? What do we call that one? Yeah, Jackson?
Quadratic.
Quadratic. And how about degree 3? About Ethan?
I don't know.
Not sure. Anyone help him out? What's degree 3? Yeah?
Cubic.
Cubic. So some polynomials have special names. Degree 0 is constant. Degree 4 is quartic. Once we start getting above those names, or those degrees, we generally would just say, I have a polynomial of degree 7. We don't necessarily use names anymore. But these are names we definitely use. Linear, quadratic, cubic, sometimes quartic. That's degree 4. Now, the nice thing about polynomials, the domain is very easy. For every single polynomial, the domain is all real numbers. There's two things you're not allowed to, there's two things that could give you a problem with domain. A fraction with a letter in the bottom, and the square root with a letter underneath it. When you have a polynomial, you are not allowed to have fractions with letters in the bottom, and you're not allowed to have square roots with letters in the square root. So the two things that would give you a problem for the domain are not allowed with polynomials by the definition. So domain is all real numbers. Bless you. The range depends. Okay, range depends. If you think of like a parabola might go up forever, or it might go down forever. Could be one of the two. Or if you think of a cubic, it could go up and down forever. It could do both. So cubic, so we've studied linear. Okay, linear, just y equals mx plus b. Quadratic is a parabola shape. Cubic, we've done a little bit, but not as much, so I want to write that one down. Cubic functions always have the behavior where one side heads down and the other side heads up. In fact, any odd degree polynomial will always have one side of the function going down and one side of the function going up. Any even degree polynomial will always have both sides doing the same thing, like a parabola, up and up, or down and down. The difference between a 4th degree and a 2nd degree is you can have more twists and turns in it. But it's still the same basic thing happening on each end as a parabola. Up, up. And you could flip that over, and it could be down and down. Okay. And if you do a 5th degree polynomial, 5th degree looks similar to a cubic, but it can have more turns in the middle. So a 5th degree could look something like this. Still has one side going down, one side going up. But a 5th degree can turn 4 times. Can turn, doesn't have to turn. 1, 2, 3, 4. Just like a cubic can turn up to 2 times. 1, 2. Doesn't have to turn 2 times, like in this one. It starts to think about turning and then it never does. Okay, so if you subtract 1 from the degree, that will tell you how many times it could turn. Okay, so let's graph that one and find the domain and the range. Okay, so we've got x to the 4th plus 5x cubed plus 2x, oops, not like that, plus 5x cubed. There we go. Plus 2x squared minus 8x plus 1. What's the domain of that one? Well, Jaden, what's my domain?
All real numbers.
All real numbers. Don't even have to think about it with a polynomial. Always all real numbers. Right. Range, well, that I don't know. But I can graph it and figure it out. Okay, so let's start with domain. All real numbers. And range. Well, does this polynomial look like it goes up forever or down forever? Nick.
It goes up forever.
Yeah, it goes up forever. So then that means it does not go down forever. It's an even degree polynomial. Both ends of the function are going to go the same way. How am I going to figure out where the bottom, where the lowest value in the range is? Anyone remember what we can do on the calculator? Second calc. Yeah? Yeah, which one in this case? Minimum, right? We're trying to find how low this parabola goes on the range. So pick a point to the left, to the right, and do your guess. So the minimum value is negative 11.95. And it does reach that. And the highest value in the range, it never stops. So that's how you find the range of that. Not something we're going to do by hand. You would just graph it and look at your graph. Okay, so 5th degree polynomials, I kind of showed you one. One end goes down, one end goes up, and it can have up to 4 turns in the middle. Okay. When a graph takes a turn, you get what's called a local minimum and a local maximum. The reason it's called local is because local doesn't mean it is the lowest value the function ever hits. The lowest value this function hits is negative infinity. I'm just saying that this value is lower than everything else that is around it. And a local maximum is a value that is higher than everything else around it. In order to get a local minimum and a local maximum, your slope needs to change sign. You go from a positive slope, you hit a 0 slope, and then you go back to negative. Where the slope is 0, perfectly flat, that is where you get a local, together those are called local extrema. Okay? So local extrema are where the slope hits 0. There's a change from a negative to a positive, or a positive to a negative. Positive to a negative gives you a local max. Negative to positive gives you a local minimum. So I kind of already said that. Local maximum is a point that is higher than all other points. That's kind of a simpler way to say it. Talking about the slope changing, that's a much more calculus-oriented way to say it. Do you really want to think about that slope changing and hitting 0? when you have a local minimum or maximum. And as I said before, local minimum or maximum are known as extrema. Now, because your slope hits 0 at a local extrema, you can find, when you take calculus, you'll learn how to find the local extrema without using a calculator and doing minimum or maximum. For us, we're going to do minimum or maximum. Okay, I'm not going to do both of these. One of them was minimum, one of them is maximum. I'm just going to do the minimum. Two things you have to understand when you're finding a minimum. It's a coordinate. The x value is where the minimum occurs. The y value is what the minimum is. So you have to understand the difference between the two. So x cubed minus 4x. So we'll graph it. Okay, it says find the local minimum. In this case, there is only one. Second calc, minimum. And I think we did minimums and maximums last week or the week before. Okay. So that tells you everything you need to know. What is the local minimum and where does it occur? Okay. This and this are two different things. They're each part of the coordinate for the minimum. This is what the minimum is. So if I said to you, how low does the function actually go in this region? You would say it goes down to negative 3.08. And then if I said, where does that happen? You would say that would occur when you plug in 1.15 or 1.1, yeah, 1.15 for x. So the x is where it happens. The y is what the minimum actually is. Any question on the difference between the two? It's the same for maximum. Where the max happens and what the maximum is. Okay, so the last thing is increasing and decreasing functions. Can anybody tell me between what two letters is that function increasing? Yeah? B and C. Now, technically, we don't include the B and we don't include the C because at the B and at the C, it's flat. It's not going up or down. It has a slope of 0. Where is that function decreasing? Oh, Travis?
Would it be A, B, or C and D?
Yeah, it's decreasing on two intervals. A we could technically include here because A, it's not flat. A is almost vertical. So between A and B, it's decreasing. Or between C, which it's flat, and D. What happens, and I kind of hinted at this earlier, but what happens as a function goes from increasing to decreasing? What ends up happening on the graph if you go from an increasing slope to a decreasing slope? Yeah? You get a local maximum. Yep. And the reverse of that, if you go from a decreasing or a negative slope to an increasing, you get a local minimum. Okay, you really want to think about these things as in terms of the slope too. Okay, so as you go from a decreasing to increasing. Okay, decreasing means you're going down, increasing means you're going back up. You get a local minimum. About that. Okay, so let's finish up with this. Let's find, it's the same function we just used. Find where it's increasing and where it is decreasing. Okay, so x cubed minus 4x. All right, so what I try to do is think of those 2 points. Those are very important. And we are going to be increasing from negative infinity right up to that point. I don't think we found that one, but it happens to be symmetrical with the other one. What was the x value on this one? Yep.
1.15.
All right, this one just happens to be negative 1.15. That doesn't always work that way. But we're increasing from negative infinity up to negative 1.15. Or we're also increasing again from 1.15 to infinity. That's how you describe the intervals where you're increasing. Here and there. And then we're decreasing between those two numbers. Negative 1.15 up to positive 1.15. Again, do not always assume that these numbers are just negatives of each other. Most of the time they're not. But that's how you describe the intervals where you're increasing and where you're decreasing. And that's 3.1. So there is a lot on the calculator for this one. Page 149 is mostly on the calculator. But just write down, if it asks you to find a min or a maximum, just write down the result. There's not as much work to really show. Yeah, so the second page is the minimums and maximums and describing the increasing and decreasing. And the first page, that's on the inequalities and factoring them. And for the rest of the week, we will be doing one section each day. Okay. Today was the only day that we did two.